Hello everyone. I'm pleased to open this session. My name is Milo Monnier. I'm PhD student in IRRSTEA of Montpellier in the TETIS lab, which is specialized in spatial information and remote sensing. My initial training is in geomatics, in geography and geomatics. Today I'm gonna make a presentation about the network-based approach of an original network, the tomato. So why did we got interested in tomato? First, because there is a growing interest in urban food supply nowadays, and its resilience, in its efficiency, more and more. But there is a lack of data. In fact, we don't really know how great cities are supplied, and this question of food flows is a growing interest in research and public actors. So the INRA ordered a study last year to collect data with a survey among distributors, intermediaries, and producers. And we studied several products, tomato, egg, and bread. But today I'm going to focus on tomato because this is a more interesting product. This is a representative product of urban food systems, which involves both short food supply chains and long supply chains. So today our network objectives with IRRSTEA. This is the study which began in INRA, but we continue it in IRRSTEA. And in IRRSTEA, our objectives were to build a spatial network of the interconnected supply chains with this raw data, and second, to assess its resilience and its efficiency in terms of network approach. So to do this, we need to develop both resilience and efficiency metrics and generate scenarios, theoretical situations to compare our observed network and to position it in a wide range of possibilities. And the aim of this work is to highlight the necessary trade-off between the resilience and the efficiency which characterize all supply networks, in fact. So to summarize what a food system is made of, we can caricature it in two extreme models. First, the short food supply chains model. They are more and more promoted by public actors and research because this is a way to increase the producers' incomes, to make stronger social ties around the food system, and leads to a decentralized power network. So these reasons are more resilience factor. But however, these models require more effort from actors and especially the producers to deliver the food and from distributors to collect it. So there is a question of efficiency behind this. Conversely, in the mass retail model, based on centralized decisions, this model allows more efficiency, more opportunities to optimize the logistics, the collect, and the delivery of food. So it facilitates, makes the life of producers and distributors easier, which limits the interaction and offer more commercial relations to everyone. But in fact, it leads to weak social ties, and we don't speak here about the social and economic issues of the mass retail model, but we will focus on its network. The main topic is the network approach, and here it can lead to the hub dependence. In fact, the mass retail model is founded on distribution centers and hubs. So between these all two situations, there is a wide diversity of supply chains and actors, like medium actors such as wholesalers, who are supplying, for example, organic shops, specialized shops. So this is not two disconnected world, the short food supply chains and mass retail. This diversity can be seen also as a resilience factor. The natural balance, in fact, of the system we can observe is not all short or all long. It's more balance between the two. And this is the product of an evolution, and the system is still evolving. It can evolve in a realistic range towards more short full supply chains and resilience, or long supply chains and efficiency. Our approach will be not just to limit on this realistic range, but generate theoretical situations on a wider space of possibilities to position our networks in terms of the metrics I'm going to develop. So how did you, let's start, but how did you collect the data? This was a survey I was involved in. It began with distributors. We began by a face-to-face interview of 15 minutes with them. I was most involved in this part of open-air markets and some colleagues on more mass retail. And once we have identified the suppliers of these distributors, we interviewed them also, and just to trace the supply chain from down to upstream. We made a snapshot. The data I'm going to show you is a snapshot of the Montpellier supply in summer. It would have been so much difficult to make it in winter, because of course in winter the supply is more from Spain or Morocco. It would be more difficult to meet these actors than in Montpellier. So with the whole raw data, we only kept for the network approach a small part, a half part of it. We eliminated the incomplete supply chains for which we did not go until the producer. So it led to a network of 152 nodes, and composed of short food supply chains in green and long circuits in red. And finally we kept half of the intermediaries. We identified about 40 intermediaries, but we kept only 17, which are interfacing more than 200 head long circuits. So here for the network, and then I made it a special network. First, I located the nodes thanks to that public database called the CIREN database, maybe well known. Every actor, not every actor, but a majority of actors had a CIRET number, which is a unique identifier of a company, an establishment of a company, precisely. So I could have located them thanks to this CIRET number. Some didn't have, so I located them manually. And then I use these locations to compute the raw journeys between them, and I generated the geometry to make them up. But the main topic is the spatial distance between the nodes, and I use raw distance and travel time. I will use more travel time also. So remain my objective is, from this observed situation I show you, is to position it in a wide range of possibilities characterized by the metrics of efficiency and resilience. So to do this, I generate scenarios which can be both more resilient or efficient in terms of the metrics, which are the efficiency metric I use is I consider it as the ability of the system to put in relations the down and the upstream actors with the minimal effort from them, which means the minimal of interaction, their degree. So, for example, in the short food supply chain scenario, the degree of the producers and the distributors are higher than in the middle range scenario, because the intermediaries allow to develop more commercial relations and more opportunities for them, upstream and downstream. In the centralized scenario, the efficiency is maximal because everyone can access everyone with one interaction only. But conversely, this system is not resilient and not robust in terms of network, because one attack on the hub, which would be a distribution center, one attack could make collapse the network very fast. So here is a question of efficiency, resilience, which can be balanced by in the mid-range situation. We need two deletions of the hub to obtain to decrease the supply availability in this network. One distributor left is still supplied, and in the short-foot supply chains, for the moment, we don't delete any intermediaries, so we consider that the resilience is maximal, thanks to direct relations. Here is, for the moment, I kept the resilience in the title of the presentation because my main objective is to develop a true resilience, which defined by ability to adapt to disturbance. But for the moment, I have a more which is defined by robustness index of a network, which correspond to this. It's going to be improved and to reach the resilience, in fact. So the way I use to generate my theoretical situations is based on rewiring. I play on two axes, in fact. On the vertical axis, on the one hand, I shorten the circuits. I replace the long by shortened supply chains. And when I do this, closest nodes geographically, closest nodes are more likely to be directly connected and jump to the intermediary, which is once is useless, is removed. And conversely, in the lengthening process, I rewire through an intermediary, and this intermediary is more likely to be chosen if we minimize the overall distance traveled between the producers and the distributor. So here for the vertical axis, I played all the circuit length. And then I play on the concentration of the flows through the intermediaries in the centralized scenario or in the decentralized scenario through intermediaries. In fact, I use the principle adaptation of preferential attachment principle, which is in the unbalancing, I take to the poor intermediaries to give to the rich, and in the rebalancing, I take to the rich to give to the poor, based on probabilities to choose the new one at each time step. So, in fact, I need to combine these whole situations to reach what I want, which is both resilience and efficiency. I made a little animation to show the results of what's done. I need to associate the unbalancing and lengthening to make converge all the short circuits through intermediaries, and then I concentrate the intermediaries. At each time step, every event has a probability to occur. So I feed them for the moment manually to make it match, to make it converge towards what I want. And in the resilience scenario, it's inverse. So before my main results, I'm going to present some characteristics of my network. In terms of just network, the average supply path length is almost 2 because of the importance of intermediaries in our network. Number of components is about 12 because of isolated short-foot supply chains. And the maximum supply path length, which means the diameter, is 4. What about the travel distance? You can see that short-foot supply chains just between the producer and the distributor are relatively made on shorter distance than long circuits. And in long circuits, in fact, we see that distance between the producers and the intermediaries are significantly higher than the distance with intermediary and distributors. It means that the intermediaries, their goal is to be close to the distributors. And this is what we keep in mind when we generate theoretical situations and spatial allocation. So I come back to my general framework of positioning it in a space of possibilities. Here is my original situation, and here is the results in terms of metrics of the rewiring process I show you. So we clearly see that these two metrics are a trade-off. So the curves are crossing like that. But for the moment, our original situation seems to be very, very resilient and not very efficient. Why? Because it's an ongoing study, and it means that I should improve. It's time now to improve the model with spatial distance in terms of metrics, because I didn't include it for the moment. First, spatial geography of food production should be integrated implemented in the resilience. I focused on the intermediary dilation, but we can imagine that food regions can be affected. We can cluster all the spatial nodes in one region and collapse this region for example, simulating a climatic event, extreme climatic event. This is a possibility. And the efficiency, maybe to weigh the efficiency in a relevant way with the spatial travel distance. But it's not sufficient just to add the distance traveled by individual flows, because this is not how the food system is made. Food system is made of a trip made by intermediaries, which means loops. It's not direct. So this is where we have to manage it. So I said in this work, we built a spatial network. We developed the resilience, first resilience and efficiency metrics to highlight this necessary trade-off of supply networks. And in further work, we're gonna implement the spatial dimension more and more into the metrics and into the rewiring model to weight the preferential attachment by geographical distance and to attach to a node maybe in the imbalancing, which can be richer, but richer in a reasonable range of distance from it. And this is going to be fitting realistic optimal models. And at the end of the main objective of this project in the framework of my thesis is to, in fact, assess the cost of a change towards a more sustainable, which is efficient and resilient network. In fact, what are the operations, small rewiring process, which can be made to improve the resilience and the efficiency of the network. For example, to add an intermediary, we call it spatial allocation, to reach an optimal network. So thanks to all my supervisors and my director of IRRSTEA and people from INRA with who I did my internship, and I collected the data. And thank you for your attention. Yes, question.
Thanks, Milo, for this interesting presentation. Your question, please.
I'm not sure if you told it, but do you take into account the volume of production that is sold by
Yes. We began, of course, to ask for the volumes into the interviews. In fact, we collected it for 2/3 of tomato flows, most between distributors and intermediaries. But we didn't really have the volumes between the intermediaries and the producer. And this is the main difficulty. So, of course, we wanted to give a more realistic insight of what is food system. But it was difficult to deal with the commercial secret of mass retail, especially.
Yes.
Do you plan or do you would like to now discuss with the people that are actually working on moving those tomatoes and showing these kind of things and discussing with them? Is it possible? Or
You mean the actors we interviewed? Yeah, we gathered them 2 times after to make a. First time it was in 2008 in September, just at the end. We were still on the survey, and we gathered the actors. In fact, in this kind of meetings, only responsible of professional organizations and which are already involved as a representative in the representative function term. But many people came to our meeting, and yes, they like to see the maps. Say, okay, the sum of all our commercial relations is this spatial network, and they provided more data. Sometimes more they talked about us, and we continue the survey. We gather them a second time, but more to give this insight. This is the informatics side of this work, because I'm making an informatic thesis. But in fact, the resilience assessment, there is the study of INRA was more qualitative, and what we explored, in fact, in the survey is: have you already been affected by a disturbance in the system? How did you react? How did you plan the next? What do you do? And it's not to be pretty hard to put it in informatics, but this is the thematic main points.
There is another question, please. Maybe I have one. So here you are generating a lot of theoretical scenario, and you place it in the space of efficiency and resilience. But have you some constraint, realistic constraint about, let's say, some relation which is not here between producer and, I mean, you generate a theoretical graph, but is this all graph correspond to reality of interaction between producer and...
You know, when we overpass the realistic range, when I put the bound between the realistic and the unrealistic, I think the key is the spatial distance, because you have when you're a producer, you have a range of interaction. This is a range of interaction which can be weight, but at the end, of course, the metrics are going to be smaller. So for the moment, I kept it unlimited. Interaction are unlimited, but I already implemented the interaction range to not to create short circuits if between, for example, a producer from Brittany, and this is impossible. In fact, so I generated, but
there are some temporal constraints also. I mean, some producer work, for example, in December, other in another month.
Temporal.
Yeah. Maybe.
I don't know.
I mean, there is always producer and intermediate person who can work at the same time of the year, let's say, so you can create the edge between them in the graph. I don't know. Create commercial relations from nothing. This is what I did first, but I choose to limit on the existing commercial relations, direct or indirect, and to play on this balance. But of course, I was concluding with adding more local things with an efficiency metric weighted by spatial distance would be the good. Intuitively, it would be the good decision, and this is what we can do. Also, in a limited, what I have to implement is the capacity of the node. I can't make explode the degree of a node because it can't. But I don't have the skills, in fact, to implement the capacity of a supply network. I know this is a classical problem of max flow, and I'm taking suggestions about this subject. Thank you for the question.
When during the rewiring process, did you? I mean, I don't know if you take into account. Maybe we have to take into account the way the food is moved from one point to another. Is it by truck or by railway? And because you cannot create a link just theoretically without taking.
Everything is on track. In fact, we have small trucks and grid trucks. One longer distance, it's of course if the trucks are longer. We collected the data about how do you do this. Sometimes the producer uses a classic car, just a car to deliver it. Sometimes a truck. So we have the data, but not for all links.
maybe I don't know if it, but everything is on the road. That's why
Okay, this is only
everything is on the road.
so-
The train has been the train on food supply in Montpellier. Before there were a train. How can I come back? There were a train to the main coming here. Here is the national interest market, the MIN, Marché d'intérêt national, where are located all the wholesalers who provide then specialized shops, especially, and mass retail. There were a train from Perpignan, but it has been deleted since some decades ago.
Okay, so it
No
doesn't
more
exist
train.
anymore.
And no more plane. So,
Why did you work on the tomato? Because this is I know that there's a lot of tomato come from
in winter?
Morocco, for example,
Mm-hmm.
to I think it's to Perpignan.
Yes, and we went to Perpignan, we went everywhere in the region on all logistic platforms to meet them, of course, but there is a balance. In fact, the European market, you have a incoming price, and we limit from June to September, we limit the entrance of Morocco tomatoes legally. There are many tomatoes which are coming illegally, but illegally, people with a serial number, usually, it's not forbidden, of course, they can. But in fact, the French market is sufficient to provide tomatoes for everyone, thanks to the Brittany, in fact. Most of our tomatoes, a third of our tomatoes are coming from Brittany. This is what surprised us. But Brittany has, before it was Provence, say south of France, who was the main producer, and now it's Brittany. Because I don't know how to say, with climatized dessert, they are champion in the mass retail, and they flood the mass retail in France. It's come from Brittany.
Sometimes the consumers go directly to the producer to take the food. So did you take into account this direction, or not? Is it from the producer to the consumer, or maybe you take into account the fact that it can be the contrary?
Who is making the travel?
Who is going to?
Who is going to?
Yes. Is
Yes.
the food going from the? I think this is what you did, the producer to the consumer, or maybe sometimes it can happen in some situations, organizations, AMAP, for example, where the consumers go directly to the producer to take the food.
In AMAP, this is usually producer which is coming into the CD center. This is a.
So maybe AMAP is not the right.
Yeah, but
example,
the direct selling at the farm. Direct selling at the farm, yes.
Yeah.
I have two direct selling at the farm, which is a flow of length, some meters, and then I didn't, of course, I didn't, but the volumes involved are. Yes, but to deal with who is making the journey and who is not, and who between the social and the spatial network, to deal with these two layers is. If someone has already worked with a multi-layers network involving spatial and social, and because sometimes the location is not the people, and sometimes it is, I'm interested in to discuss about it, about this aspect.
No other questions? Thank you very much, Miguel.
Thank you.